So let me do a quick introduction to the new mathematical tool we are going to introduce. And let me tell you why we are introducing this. Because so far you might think, all right, we have this circuit. We use these functions that we already know, and all of that worked fine. Why do we need anything new? It's because I'm looking ahead to how to model this more realistically. When you looked at the demo, it wasn't in the demo. The oscillation, it didn't go on forever, as our solution here would have predicted. This oscillation, it kind of died out. It, oscillation starts, but it gets smaller and smaller, and this is the actual demo that you see. And what you're seeing with this dying out of oscillation is the loss in energy. So the oscillation itself is the energy sloshing back and forth between the capacitor and the inductor. Energy was stored in the electric field, later it's stored in the magnetic field, and back and forth. But as it goes back and forth, it loses some energy each time it goes around. Why? Like in the real setup, in this, where's my circuit? In this real circuit, why did it lose energy as it goes through these cycles? Heat, I'm not sure if I want to say entropy, but heat, yes. So as current flows, this has some resistance. So that resistance is going to dissipate power as joule heating. So a realistic model of the circuit has to include a resistor here. There will always be some resistance. That's what's responsible for this loss of energy. And what that will end up is that when you go through all this, it'll add a term here. It should add a term that looks like minus, it's IR, so minus R over L dq dt. It's going to add this term here. And now when you try to do the same thing here, use this as your guess to the solution to here, you'll find that it doesn't work anymore. Because when you take the single derivative, you don't get the same function back. And using this as the guess, it doesn't work. The guess that actually works is the more complicated one. It's going to look something like this whole thing times exponential of something times time. So it's a very complicated functional form, which means the tools that we have been using are not adequate. If that's all we are limiting ourselves to, then we can deal with the LC circuit, but we cannot deal with the RLC circuit, which is the more realistic version of the LC circuit. So, but I think that should be within your reach. The kind of math that you have covered, pre-calculus, is already actually covers what you know. It's just that in none of your physics classes so far, you have seen someone actually use what you already know mathematically. So let me remind you of what you already learned in pre-calculus. A lot of people do forget it, so that's why I'm going over this. So I would put this under a heading of complex exponentials.